Hi members, thought of dropping a concise video on Java records. In this video, we are going to address these three questions. What is Java record class? How to write Java record class? And what's the difference between Java record and normal immutable domain class? Record classes are new style of class definition that we can write in Java language starting from JDK14 as a preview release, and it got extended in JDK15 by adding another feature called local record classes. Now firstly, let's go ahead and understand the way we create a normal immutable domain classes in Java so that we will be able to answer all these three questions step by step. So the first thing is going to the creation of a normal immutable class in Java. So I've created a banking application project, a pretty simple project. And here we have a couple of packages. One is the root package, which is com.barclays.app. Another one is com.barclays.app.domain. Under the domain package, I've created a banking transaction class, the one which you can see here. And this banking transaction class is declared as final. So most of you might be aware of how to create an immutable class in Java. Yes, of course, the class should be declared as a final class. That's the very first rule that we have to follow. And we need to have all its fields declared as private and final. So that's which I'm going to do right now. So I have a set of final fields readily available here. So let's go ahead and import the local date. And now you can notice that we have to create an argumented constructor correspondingly to all these the final fields that we have declared here. So what I'm going to do right now is I'm going to make use of the IDE feature of generating the argumented constructor for all these fields in order to create an immutable domain class. So we mark it as a domain class. So we quickly go ahead and generate the argumented constructor. For that, we go to the source menu and generate constructors using fields that we have declared. So all the 5 fields are listed out here. So for correspondingly to all these 5 fields, we are going to generate an argumented constructor up here. So now argumented constructor is defined and we have all the fields declared as final and they are all marked as private, as you are aware that the fields cannot be accessed outside the class and it should not be. And the field value cannot be changed once after it gets initialized. So that's why we mark it as final. And these are all the set of rules that we have to follow in order to define an immutable domain class in Java. So the third thing is accessor methods. We are not going to carry the mutators, that is setters. Instead, we are going to use only the getters, because setters are basically used for setting the value for the field once after it gets initialized as well. But as per the rule for immutability, we are not supposed to change the value of the field. So we are not going to carry any mutator methods, that is setters. Instead, we are going to carry only the accessor method called getters. So for that, again, we are going to use the IDE feature to generate the getters code. So I'm going to select only the getters, not the setters for it. That is, accessor methods are alone going to be generated. So here we go. For all the 5 final fields of this class, we have generated the accessors. The next ceremonial set of codes that we have to generate is toString method. Let's go ahead and generate those as well. So generating a toString method. The next is hash code and equals method need to be overridden from the base class of this class called object. So we are going to generate the hash code and the equals method as well. So this is a traditional way of writing an immutable domain class in Java. So the rules are: a class should be marked as final. It should have private fields, mark them as final as well. And we need to have an argumented constructors in order to initialize the value for these fields. And we have the accessor methods, that is the getter methods. And we have the traditional ceremonial codes like toString method, hash code method, and equals method. Now, if you notice that most of the codes are auto-generated with the help of IDE feature. We as a developer, we can write all these codes, but as we use modern IDEs, we have more advanced features which can help us in auto generating the code for us. But ideally, what this record is going to do is, this record is going to eliminate all these ceremonial codes that we use to follow in creating an immutable domain class. That's the big difference. The easiest part here is records are meant for reducing the ceremonial code. So that's what is defined here. So record classes help to model plain data by writing less ceremonial code than normal immutable domain classes. So motivation for this is to reduce the introduction of the Java records is to reduce the ceremonial code, because Java follows more verbose code and it follows more ceremonial code as well. So the idea of introducing records here is to reduce those ceremonial codes. Anyways, before we create a ceremonial code, let's go ahead and make use of the one which we have created right now. That is a traditional immutable class called bank transaction. And let's go to the application, the main application code, where I'm dropping the object which I have created and hold it readily. So let's go ahead and import the package, the bank transaction. If you notice that this is this is an object which I've created for this class called bank transaction, and the bank transaction object is going to be dropped inside the sysout statement to see the values of this object. So through the constructor, we are setting the values, as you can notice here, right? So we are going to print the object and see what are all the values that is available inside this object. So let's go ahead and run this. So run as Java application. Now you can notice that we have the values assigned for the corresponding final variables or the fields of this particular bank transaction class. Now later we cannot change the value of these fields. That's number one. And we can only get the values, but we cannot set the values because we don't have the setters. The mutators are not there. Only the accessors are present here. So this is a traditional way of writing an immutable domain class. So it works intact, no problem. And the class is also declared as final because as per the rule of immutability, we are not supposed to allow a subclass to get created out of this base class. So once the class is marked as final, we cannot create a child class of this superclass from this base class. So we follow all these tradition in order to create an immutable domain class. Now what I'm going to do is I'm going to create a record class. So let's go ahead and create a record here. So as you can notice, I'm using a Java SE 17 version, means I'm eligible for full access of this record without the preview release or preview feature enablement. So in 14 and 15 it was preview, but from 16 onwards we can access the records with full feature without enabling the preview options. So that's the advantage. So here I'm going to create a record. So right click from the package of the domain and you can see that there is a new element called record is available in the menu list. So similar like how we create a class, the same way we can create a record. So just click on the record and I'm going to give a name for the record called transaction. Just finish and here we go. So in place of a class keyword, like in bank transaction, we had final class, but here we are using a keyword called record. And we have the name for the record called transaction. This is a header part. This is the header part. And next to the name, we have a parenthesis. So what is the use of this parenthesis is to drop all the components. So these are called as components inside the record class. So we are going to drop those fields. So here what happens is the fields that we have written inside the bank transaction, which is explicitly a private and final, when it comes to the record, we are not going to say anything as an access level, or we are not going to say anything with a keyword like final. just drop in the fields, but these are called as components for this record components. We will not call them as fields, or we will not call them as variables. Instead, we will call them as components. And that's it. That's it we have to do here. Just drop the set of components that you want to use inside the record. Now what we are going to do is go back to the bank app. Now we used the traditional immutable domain class here, but right now I'm going to use the record. So in order to do that, the record name is transaction, so I already have an object for it. So we can create an object for the record as well, because it is going to be considered as an immutable class. Drop it here in the sysout statement and run them. So you can notice that similar output of the bank transaction is what we are seeing for the transaction object as well. But the difference here is bank transaction is an immutable class. Explicitly we have declared the class keyword, final keyword, set of private final fields, argumented constructors, accessors, and other ceremonial codes, which includes toString, hash code, and equals. But here in the record, we haven't written any such ceremonial codes. We have just dropped in the components, that means the fields, which need to be a part of this record. Is this record and this immutable class are going to be same? Yes, of course, it resembles the same. So we are able to create an object for the record class. It's a special type of class, right? It's again a class. So we are able to create an instance. We can drop the values for all the components of this record. So what are the components we have here is transaction date, details, amount, debited amount, credit amount, and balance. For all these components, we are able to pass the value as well, which is via the constructor of the record. So do we have a constructor here? Yes, of course. It is called as canonical constructor. The meaning of canonical constructor is the constructor is auto-generated. That is, the argumented constructor itself is going to be auto-generated based on the availability of the components that you have declared here. So you have 5 components declared here, so that it will create an argumented constructor carrying 5 arguments in it. So it is called as a canonical constructor. Inside the record, the canonical constructors are the one which is auto created by the compiler itself. So are we able to see those auto generated codes and methods? Yes, of course we can do that. For that, what we have to do is just go to the project location, where we will find the binary directory, and you will see the set of packages that we have already declared. Inside the domain package is where I have dropped the record class. So this is a plain traditional immutable domain class, but this is a modern way of writing the immutable domain class via a record class style. So from the domain package, I can launch a terminal screen. So from the terminal screen, what we have to do is we have to use the tool called JavaP and use the transaction class file. Okay, provide the transaction.class file as an argument to this JavaP tool. Okay, and hit enter. It will decode the bytecode. As you can notice that the transaction is declared as a final class. So what we have here is record. So if you just go ahead and see the difference. So what we can see here is record keyword, but what compiler had auto generated is the traditional way of declaring it as a final class, and it extends the record. So there is a base record class which is a part of java.lang. So we can see that here in the documentation as well. So there's a class called record. So what is this record is? This is the common base class of all Java language record classes. So any record class that we define, that record class is going to extend this record class. So that's what the compiler have done here. Then we have the argumented constructor, as I stated. Even though this record seems to be empty, the declaration, the definition of this class or the record style of class seems to be empty, but the bytecode is carrying the relevant ceremonial codes as well. So I can see all the accesses, but the style of accesses here is without the prefix of get. There's no get keyword prefixed here. Unlike our traditional immutable domain classes, we have auto-generated the getter methods by prefixing it with get. That's not there. And we have toString method, we have hashcode method, and we have equals method. So all these are the ceremonial codes which are auto-generated in the record, bytecode, in the record class with the help of compiler. So these are compiler generated code. So this constructor is going to be defined as the canonical constructor, and the constructor name and the record header name are going to be same. Based on the number of components that we have defined here, the canonical constructor arguments are going to be mapped. Moreover, we can also explicitly write a canonical constructor if in case you want to do some business logic or do some validations before you assign a value to these final fields. You are going to make an explicit canonical constructor to be written here. Now, one more thing is all these fields are by default going to be observed as a final fields, like how we have declared here as a final fields, private final fields. The same way, all these components are going to be private final by default. So the advantage of record is to reduce the boilerplate code or to reduce the ceremonial codes that we used to write in a traditional immutable domain class. So this is not the only advantage of record class. Record class can be used in many scenarios, and we can also write a local record classes. When we are using Java 8 features, record classes would play a major role. So going forward, instead of creating a traditional way of immutable domain classes, we can shortly write the record classes or record style of classes. So can we able to define static variables, static methods inside a record class like how we do it in a normal class? Yes, of course we can do it. Those are all more added features that are part of a record. This is a separate record class that we have created. We can also write a record class inside another class that becomes inside a method that becomes a local record classes as well, which got introduced from the version of JDK16. So we have more advanced discussions as well on this record, but I just want to keep this short and concise so that you'll get some base idea of how and when to use the record style classes in Java going forward. Thank you all.